Now I'm going to move on to showing you how an X bar chart works. I already showed you the individuals chart. So I'm going to open the data set that is labeled SPC X Bar R. So there's two tabs here. Just to make things simple, I'm going to go to the all data in one column. So in the previous example of the individuals chart, we just had a single column of data values that we plotted in a time series chart with upper and lower control limits, and the average, and then some other features and things we can do to that chart. In an X bar chart, this is where you're plotting data that is grouped. So rather than plotting the individual values here, what we're going to plot is the averages of those values. So this first column is the time to trade. So presumably this is some kind of data from like a financial trading desk or stock trading desk. And what we've done is we've taken a sample of 5 trades from each day. And so you can see there's 5 from day 1, 5 from day 2, 5 from day 3, and so on. And this goes on for 1,200 sampled from 20 days, samples of 5 for 20 days. So rather than plot all the individual values, what we'll be plotting is the averages for each of those days. An X bar chart is particularly useful when you are plotting something that occurs frequently. If you have something that happens multiple times a day, but you want to plot that data over months, it can get really cramped when you're plotting every individual value. It can be impossible to really see what's happening. So instead, you plot the average from each day or the average from a week. Or maybe you have a process that's going on for a longer period of time. If you're looking at that process over the course of months or years, you may plot the averages by month, or whatever is appropriate. So so when you're plotting averages, that average is represented by X bar. If you remember on the individuals chart, when it showed the average, it said X with a bar over it equals the average. X bar stands for average. All right, so I'm going to create the X bar chart. I go to Stat, Control Charts, Variable Charts for subgroups, and then you go to X bar. It's assuming that all the observations for the chart are in one column, so all those values are in the first column, time to trade. Then it's asking me what column is it that defines the subgroup sizes. Well, I've got those labeled here. My subgroup 1, subgroup 2, subgroup 3. So that subgroup size is determined by the column called subgroup. Okay. So what this is showing me is the average here for subgroup 1. I can see the sample mean for subgroup 1 is 20.4. So if I take these values and average them, I would get 20.4. Then I have the average for subgroup 2 and so forth. The overall average here in an X bar chart is being represented by X bar bar. So X bar bar is 20.6. It's important to note that this 20.6, it's not the average of the averages. It's not taking 20.4 and 22.8 and 20.6, adding those up and then dividing by 20. It's actually averaging the underlying data here. So that overall average is 20.6. You can see that this looks like a process that's reasonably in control. We have our upper and lower control limits. Upper control at 26.98, lower 14.22. Though it does look like there is a bit of a wild swing here in the middle. You can see how different this looks if I plot the individual values. So just to show you what that looks like. Go to stat, control charts, individuals. And here I'm going to plot the time to trade. So you can see how cluttered that is, how it's a little hard to get a clear picture of what's happening over a longer period of time. And you can imagine, if we did this for instead of 20 days, did it for 40 days, how cluttered this would be and how hard this would be to see what's going on. Now, it does appear that we've got, when we look at it as an individual chart, we do have an outlier here, but that's one value on one day. We've got at least 5 in our sample from that day. So the X bar chart is useful for looking at lots of data over time. It's particularly useful when you're looking at data that's not distributed normally. There are other features that we can do in an X bar chart that we could apply to any kind of control chart. We could add a reference line if we wanted to. We could choose to look at plus or minus 2 standard deviations if we wanted to create a chart that was more sensitive. You can also do something that I think is important, particularly when looking at process improvement, is add stages to a chart. And you can do this in an individual's chart as well as in an X bar chart. I'm going to show it to you here. So I'm going to go ahead and do my subgroups, variables charts for subgroups, X bar, apply the same thing, subgroup sizes. And, so the subgroup sizes could be determined by a date. Right? It doesn't have to be a subgroup number. The subgroup sizes could be determined by a date. It could be determined by the name of the person who was the manager during a period, who was the shift manager. It can be anything, honestly. It could also be that you just know that every 10 or every 6 values represent a subgroup, and you can type in that number here. We happen to know that each of these subgroups is of equal size, and that size is 5. So I'm going to do that here just to show you that it really makes no difference. So what I want to do is add a stage. So if I've got a process where I make a change in that process, and I want to see how do I compare the data from before that change to the data from after that change, I can add what's called a stage to that control chart. And you find that under X bar options, got a stages tab. And it could be, again, if my subgroup was being defined by date, I could say that anything that happened after June 30th is where I want to create the stage break. In this case, I'm going to say after the 10th day, we're pulling a sample of 5 from each day. After the 10th day, we made a change in the process. Sorry, I'm using my subgroup. So I'm using my subgroup to define where that break should happen. And then I want the sort of new stage with the occurrence of the new value. So after the 10th day, we made a change. So on the 11th day, I want that new stage to start. Let's see right here. So we have the first 10 days within this stage, and then the remaining 10 days in this stage. You can see it looks like the average did not change much. Slightly, you can see when you do a stage break, the upper and lower control limits and the X bar, in this case it's an X bar chart, but these values over here will be calculated for the last stage in the display. So the average for these last 10 days is 20.64. I hover here. Click on it and hover. Come on. That's not cooperating for me. Excuse me to do it for the, there we go. 20.56. So very similar to the average. But what I can see here is the upper and lower control are much wider, right? Based on these values, Minitab is saying, well, I'm predicting that 99% of the values from this process will fall between 28 and 13. So it looks like whatever change we made on the 11th day introduced more variation into this process. You can see the first 10 days, the upper control limit is going to give it to me. There we go. It was 25.8. Lower control limit is what, 15 point something. Yeah, it's not giving it to me. I'm not hovering quite the right. Yes. Anyway, but you can see that the variation expected from the first 10 days is quite a bit less than the variation expected from the remaining 10 days. In addition to just a straight up eye chart or X bar chart, you can create a chart that also shows not just how much the individual or where the individual values fall or where the averages fall. You can also create a plot of standard deviation, right? So we're plotting the averages here. So this is an X bar chart. A plot of standard deviation would be an S chart. And you can do these in combination. So if I go to control chart, do charts of subgroups, I can do a standard deviation chart by itself, or I can do a combination chart that shows the plot of the averages of the subgroups as well as the standard deviation within each subgroup. So I'm going to do time to trade, subgroup sizes by subgroup. It's probably going to keep, nope, it's not keeping my stage. That's fine. Since technically it's a different tool. It's resetting the stages back to the default, which is no stages. That's fine. We'll leave it like that. All right, so now I have my X bar chart where I'm plotting. You see it says the sample mean. And down here where I'm plotting the sample standard deviation. You can see right here the X bar 20.6 like it was before. Control limits. And then here, this shows the standard deviation. Right, so we can see that it's a standard deviation of 4.4 with an upper and lower control limit around that standard deviation. So again, looking at those first 10 versus the second 10, I'm going to go ahead and add in my stages defined by subgroup. The new stage will begin with subgroup 11. So it puts the stage break on both of those. So the average remained the same, basically. I mean, centered around the same average. But what we see here is in the first 10 days, there's a lot less variation, right? That measure of standard deviation was a lot lower than it was in the second 10 days. So whatever process change happened here made this process worse, is what it appears.